Hello, everyone, and welcome to Traffic Corner Tuesday. My name is Paul Kerr, a Client Relationship Manager at SPAC Enterprise, and your host for today's webinar. We're going to leave the poll open during this brief introduction, so please, as you're popping in, feel free to fill that out. Continuous improvement is one of our core values. For us, that means completing research projects to further our knowledge and improve our understanding of transportation. Today, we'll be discussing one of our research projects, drive-through queue studies. So please join the conversation by using the chat box on your screen to ask questions or share your experience throughout the presentation. We'll try to work your comments in as we go, but we'll also be doing a Q&A at the end of the presentation. You can always email Mike or myself if you think of a question later. You can also email if you think you have a good research idea or project. The Traffic Corner Tuesday webinar series is brought to you by countingcars.com, which is part of the SPAC Enterprise family of companies. SPAC Enterprise consists of a group of traffic engineering companies focused on helping you create healthy transportation systems and fix broken ones. Please visit our websites, countingcars.com or spacconsulting.com, to schedule your consult call or discuss your needs. From transportation equipment to traffic counting to engineering studies, we want to help you succeed. Now, today's presenters are Mike Spack and Brian Fiesick. Mike is the creative force and principal writer for the industry-leading blog, Mike on Traffic. Brian is the vice president of SPAC Enterprise and regularly contributes to Mike on Traffic, as well as co-hosts these webinars with Mike. Mike and Brian are licensed professional engineers and are certified professional traffic operations engineer, and enjoy expanding their understanding of transportation elements. Completing research projects is one of the ways that they keep their knowledge up to date. With that, let's get started. Mike and Brian.
Thanks, Paul.
Thank you.
All right, thank you, Paul. All right, so let's dive right in. Some of you who've been with us for a while know we like digging into research, and by research, I'm going to say not necessarily the full-on academic, get a master's degree or PhD thesis research, but hey, we want some more data so we can make better decisions in our day-to-day work kind of data, and that's what we're going to be talking about today, is bridging that gap between academia and what kind of research data can we use in our day-to-day jobs. And most of us have been plagued by the coffee shop that is spilling out onto the street, and residents are complaining it's causing safety problems, and things are just jammed up. There's one near us that went in about a year ago, and it's made the news all over the place for a Starbucks, and thankfully we didn't work on that one.
I was going to say, that wasn't ours. So.
But this is a pretty visible area of our work, especially if we don't get it right.
Definitely. So yeah, just as Mike said, we like to think we're in that sweet spot, bridging the gap between academics and getting useful information to help us do our day-to-day. So to expand on what Mike was saying here as we move on to the next one. So this would be typical site plan that you've got, in this case for a small coffee shop. And what we're looking at, get my laser pointer here, you can see they've shown the cars stacked through their drive-through lane here. They've got what looks to be the order window here, pickup window here, but there's your stacking, and you can see where this entrance is off the main road. And so as we look at that site plan, that's one of the things we would be looking at is, do they have enough stacking? Are those cars going to go back, spill out into the public roads, block people from getting into the parking area, other things? So this is one that we would look at carefully at those aspects and what that drive-through means for it.
Yeah, and kind of philosophically, we're okay with a business owner on their private property really screwing up their parking lot. That's their prerogative and their decision. Of course, it's our ethical professional duty to let them know they may be doing that,
right?
But we're not going to raise big red flags. But if they are spilling cars out onto an adjacent 55-mile-an-hour county road, potentially creating safety issues, then we really need to, as licensed engineers, really push back against that. So that's kind of the gray area we're playing in, and we all need to recognize.
Mm-hmm. And we do have, so we show the site plan there. We do have a real world example too, and this is closer to where I live, so I know it well. Mike's been there too, but this is a coffee shop again, and the order window is on this side, west side of the building there, and you can see that the stacking there is just ridiculously short. And what happens is you get 4 or 5 or 6 cars, and suddenly they're blocking this, they're blocking the entrance to these other buildings over here. This is their main parking along there. So I mean, it just becomes a mess in the morning. So with that backdrop, let's move into our process here, our Q study.
Yeah, and we've been working on this over at Mike on Traffic and SPAC Consulting for about a decade. We've been collecting this kind of data, and really one of the first to publish anything along this. We did our initial full-on study in 2012, but here we're doing an update. And so step one, whenever we have a project, is define our goal. What are we hoping to get out of this? Mm-hmm. Why are we doing this? And in this case, it was looking over that work from 6, 7, 8 years ago. And one, trying to figure out, is that data set still relevant, or have conditions changed? And also, do we need to change out anything in the study? What are lessons learned that we need to tweak to make improvements on what mm-hmm. we did in the past?
Yep, and then ultimately take that information and then we use it in our studies. So that, like we talked about at the beginning, we're in that sweet spot. What we're doing is specifically going to relate to how we look at our sites, how we do those site reviews, and it's going to help us be better engineers.
Yeah.
So that's all wrapped into that goal.
Yeah, is really to be the ultimate professional engineers we all want to be.
Yeah, exactly. So then the second part, now that we have the overall goal, it was looking at the land uses. What type of land uses do we want to look at that's going to help us further that goal, help us in our studies? And this obviously first criteria, that they got to have a drive-through. It doesn't make much sense to look at ones that don't have it. And so for this one, we identified 5 different land uses, and these are typical ITE categories that you can find: bank, coffee shop, fast food restaurant, pharmacy, and a thrift store.
Yeah, and we added in the thrift store from our last study that we've been working on a lot more Goodwills as mm-hmm. of late, and anyone who's tried to make a drop off at about 11 o'clock Saturday morning and faced the 7-car queue that seems to take 15 minutes per car, at least that's what it seems, knows this is an issue. And we also, back in 2012, we studied a bunch of car washes, and it doesn't seem like car washes are nearly as popular. So we decided not to update. We'll probably get around to that, but it didn't feel as urgent
right now
to us.
These were the 5 categories that we see the most and have the most impact. So yeah. That's what we focused on for this one. All right, so with that, then we moved on to our third one. Now we have our categories, the land uses. Now we need to physically identify those sites. So as a Minneapolis-based company, most of our sites focused around the Twin Cities area. So it was just natural for us to do that as part of our work.
Yeah, and as we put up there in the poll, and you can feel free to email me later, we would love to add your local data into this. But since this was for our own selfish consulting needs, we haven't branched out and flown out across the country to collect this data quite yet.
At the moment.
But we would love to add your data, get you up to speed to help us out to add more data points and to figure out if there are regional differences in any of the data sets. But yeah, we start out and we picked busier locations. We want to do our study. We want to plan when we're doing our site reviews, assuming that this is going to be a thriving business. Mm-hmm. And we also assume that the developer and operators are picking the location, assuming it is going to be a thriving retail establishment. So that led us, at this point, we haven't looked at the variables such as what's the adjacent ADT or what are store sales or.
Yeah, there's a whole host of factors you could look at. If you think about all the factors for trip generation, we could go down that line trying to suss out the urban versus suburban versus rural and all that, but we haven't taken that step right now. There's just not enough data to really be meaningful with it. So right now it was just spots we knew were busy and spots that made sense for what we were looking at.
So then, of course, we had to get out there and actually do the data collection. And as hopefully from all of our previous work, we own and operate countingcars.com as well, where we sell different data collection devices, including a video camera system called the Count Cam. And that's how we collected this data, as we set cameras out for up to a week to collect videos. And then we used our fast forward CountPad Count Pro system to reduce the data into what are those maximum queues looking like at each of the locations. So this, if we had to do this the old fashioned way, where somebody's sitting there out 1 hour per hour of data, this would have been ridiculous. But this kind of data reduction we can do at 20 times speed. So we can reduce a day's worth of video, get that done in about an hour. So
yeah, the process was pretty quick once we got the cameras in and watched it. And again, you can look up information about the cameras if you want more. Please talk to Paul.
Yeah,
but it's the system worked very well for this one because it allowed us to go through many days of data very quickly.
Yes, and again, we measured these queues starting at the ordering window, not the pickup window, because that's typically there's the line. Sometimes they're one and the same, but there can be the lag between the ordering window and the pickup window. But starting the queue at the ordering window and working backwards
gave us that consistent spot at each time.
Yep. And if there were 2 or 3 or 4 or 30 lanes in the drive-through, we were counting the demand for the drive-through. So the total cars moving back from that ordering window, even if they could have 2 or 3 cars wide. And we'll get into that more. Yep. We think that's the right approach.
Yep. And then finally getting to that last step of just, we got all the data, we've looked through it. Now we can just analyze it. What is it showing us? What can we conclude from this? And again, turn it around and use it in our work. All right, so what we're going to go through next is we've been through the process now. Let's start looking at the results. So we had the 5 different land uses, and we're pulling out some of the key results here. So we'll start with the bank range of results. So this is just over the number of surveys we had. What was that range of maximum queue that we saw? So all these are based on the maximum queues. So in this case, we saw banks with a maximum queue of 2 to 7 vehicles, depending on which site we were at. So
as we all know, this is a land use that has changed remarkably in the last 30 years with online banking and ATMs and direct deposits. There just isn't the demand at drive-throughs the way there used to be. And this is pretty typical in my experience of seeing the 3, 4, 5 lane drive-through at a bank that was built 25 years ago that has a couple of cars in it.
So average maximum queue seems like a contradiction, but of all the data we got, we took those maximums and we averaged them together.
Yep. So these 3, those in the 85th and the standard deviation are all looking at the maximum queue for a group of sites and then doing these statistics based on that maximum queue.
Yep. So average 3.5. 85th percentile, we were up to 7. So the math basically came out to the top of the range. And then we had a standard deviation just over 2. So a little bit of variation in there, but generally as we were looking at this, as we look at banks now, we would use that 85th percentile and say, do they have room for 7 vehicles? And one interesting note about this as we were watching the videos, regardless of how many drive-through lanes they had, it seemed like most people wanted to stay close to the building. So they didn't wing out to the far third or fourth lane, even if it was open sometimes. They were just comfortable waiting for a car or two and then moving in.
Yeah, so that's an interesting finding, and that dovetails with our experience of dual left turn lanes and triple left turn lanes and dual right turn lanes, that you really need to be at capacity, have a lot of demand there to push people to balance out into all the lanes. So clearly at these locations, they weren't saturated, people waiting, so they picked the lane they were most comfortable with. But I'm sure if we had 20 vehicles waiting in the queue, all of those lanes would have
Yes,
gotten.
then they would have balanced out.
Yes.
Nicely. All right, so next up is coffee shop. And despite the picture in the background, these were not all Starbucks or one particular. We did try to vary our spots, make sure we were looking at a wide range of areas. For the coffee shop, our range was 7 to 13 vehicles. So kind of we're much higher than the bank, obviously, but still a kind of a wide range there. Average max, 9.5 roughly. 85th percentile got us up to 12.4. And low standard deviation.
Yeah, so this is a much tighter data set across the drive-throughs, and saying we should be designing for that higher end. And once we show all the summary statistics, we'll show the comparisons to where we were at in 2012. But we've gotten pushback from different retailers here when we're doing site reviews of saying, well, your data set's from 2012, and there's 4 times more coffee shops now than there were in 2012. Well, as you'll see from our data, it looks like there's also 4 times more coffee drinkers to line up with the 4 times more coffee shops. So this was very good to get this data set in particular updated.
Yeah, this one just confirmed that things are pretty close to the same.
Yeah.
One other note on this, and it's one of those that what you would expect, but the maximum queue is really concentrated in the morning between 7 and 10 a.m. So again, kind of everybody gets coffee in the morning. But it could be a consideration for something. If it's a sleepy road in the morning, maybe you're okay with a little.
Yeah, or if it's situated in a parking lot next to a place that opens up at lunch, fine. Let the queue back up and impede the lunch restaurants, because their timing is going to be so different that even if they're spilling into another use that isn't open, no big deal.
Yep. So something to consider. Again, ideally, they would have enough queuing on their own, but if you're in a tight spot, that's something you can think about. Fast food restaurant. So as we look at our statistics, 5 to 14 vehicles. Average was 8. 85th, almost 14, and this was our highest standard deviation. So
Big range.
Wide variation in what we saw here. And again, we had some different sites. I would have to go back and look at the data to say which sites were busier than others. It might have been a function of
this is one area
we picked.
This is one area of the data set where maybe we need to study Chick-fil-A is different than McDonald's, is different than Burger King, that we need to really get subset data on this instead of applying Chick-fil-A rates to Burger King. And I don't even know which one would be busier, but I'm just picking on those two, that there could be pretty big difference.
Yeah, and I would think that explains a lot of the variation we have, which we have set for trip generation and other things. If you're a repeat listener to us, we're big believers in collecting local data. So this is a good start, but if you have a specific fast food restaurant that's coming in, go out and get some of your own data and look at the drive-through specifically, because that'll help nail it down within this variation.
Yeah, so if you're working on a site plan with the Chick-fil-A and you have a couple of count cams, well, get out there and get a few days at 3 different Chick-fil-A's, watch it on fast forward speed, and 8 hours of intern time later, you'll have your own good data set locally and current to be able to make the right decision.
And then feel free to send that to us. We'll add it to what we got. Next one, pharmacy, and 3 to 6, so lower compared to the other ones, again, as you would expect. The average max Q, a little over 4. The 85th was 6, so closer together between those two compared to some of the other data sets, which shows in the standard deviation. So, and more consistency between the sites that we looked at on this one.
So the last one then is the thrift store, and I don't know about you and your region, but Goodwills are popping up all over the Twin Cities and a couple of other competing thrift store brands. Yep. So we've been working on quite a few of these, and the range and results is a pretty big range, again, 4 to 9 vehicles, and we should say that this included the peaks were on Saturdays, I believe. That when we looked over,
yep. We definitely wanted to get the weekend on this one, make sure we were covering that. So yes, included weekend numbers.
Yep, and this could be the scenario where you have Starbucks next to Goodwill. Hey, complimentary kind of drive-through lanes. And maybe Goodwill should start selling coffee. To have the average max Q, we're around 6. The 85th is though all the way up to 9, the maximum of the range. Tighter standard deviation. So that 4 range is really an outlier in this data set. It skewed higher at most locations.
Yep, definitely. All right, so those were the 5 land uses and the results. So what we did here on our next step is a comparison. So taking that 2012 data, and you can see in our chart, the 2012 is in blue, 2018 in orange, and we've got the heights of each of them mixed in there. And this is the 85th percentile Q for all those. So taking looking at the maximum of all the data we had, 85th percentile.
Why don't you explain 85th percentile for a minute? There might be one person out there who hasn't heard that.
So 85th percentile, that would mean 85%, 15% of the time it would be above that number. So you're really trying to get to what will cover you in most situations. I mean, that's essentially what we're saying. You never want to plan for a maximum because it could be an outlier.
The maximum of the maximum.
Yeah. So if you continue down that line, that could be an outlier. That means you're spending more money than you probably should. So 85th percentile is one that it gets you up close. It covers most situations, and it's what we use in other situations, speed limits.
Yeah. So so if this is a new concept to you, it is a consistent benchmark through transportation engineering is to design things for that roughly that 85th percentile mark.
Mm-hmm.
Okay. So turning back to the chart here, we can see there, interestingly, isn't a big change in these land uses, in my opinion, over the last 6 years. That the data sets are pretty consistent. So when I was joking about the coffee shops and getting pushback that Caribou Coffee is seeing a lot shorter drive-through lanes because there are so many coffee shops now, that's not what our data supports. So if Caribou or some other operator wanted us to get subset data and really dive into it for their use, okay, we'd be happy to do that.
Yep.
But kind of looking at just trends, we don't think much has changed between coffee shops or fast food restaurants or even banks. That things are pretty consistent across the board here. Couple a little bit higher, couple a little bit lower, and of course the thrift store is the new use.
The new one. Yep. So yeah, if we were taking this, I mean, if we're looking at a bank, we'd still probably say 8. Right in that area. If we're looking at a coffee shop, we'd be looking for storage length of 13, probably 13 for fast food, 13, 14, and then pharmacy, we'd be looking at 5 or 6. So that's the next step we will do on this. Now that we've confirmed that the data is relatively close to give us a more robust number. We're going to put them together. We haven't done it yet. So we just wanted to compare everything first. But by putting it together, it'll give us a larger sample size, give us more confidence in the numbers.
Okay. And maybe just to round this out, our experience is showing that a car is taking up about 20 feet in a drive-through queue that they can pack. They're 15 to 18 feet long, 15, 16 feet long, but there's obviously a few feet between. The more demand there is, the tighter they will pack in. So kind of,
but that's a straight line too. So you got to think about the curve. If they go around a building, there may be more space there. So we feel comfortable with 25.
Yep.
Because that gives you that space between and allows for those fluctuations of curves or other.
But if you're looking at an architect or a site plan like the one we showed at the beginning with the vehicles wrapping around, make sure that those cars aren't 10 feet long. So throw a scale.
Bumper to bumper and all that stuff. So yeah.
So it's a quick double check. Make sure they're at least 20. We would prefer 25 feet per vehicle in this. So if you're going to go 6 cars, we'd love to see that queue be 150 feet long. But that's cross check we'll do is pull out the old fashioned scale or do a measurement on our Adobe PDF just to make sure the pretty picture is not throwing us off.
Yep.
With that, thank you. Wrapping up here at the end. Any questions we're happy to take. If you want to type something into the chat, let us know. And we do have a draft of this report ready, and feel free to email me if you'd like to get your hands on that right now and review it. Right now it does the comparison of 2012 to the 2018 data, but we're looking at, since the numbers are close, we think it actually makes sense to aggregate them and say that the 2012 data is still relevant. So we have a little bit more work to do on that report.
So it's fair to say that this is a draft, but it can give you that basis for the numbers. We'll have that final version.
Happy to share that. We'll touch base with those who responded to the survey to see if there's any data you'd like to partner with us to help collect. And of course, if you have any data around queue generation or speed limits or lane widths, any of the research projects we do, we love it when we get localized data from other parts of the country, which we are getting more and more. So thank you for those of you who've already submitted data to us. We love that.
All right. So
with that, I guess that was just a pretty straightforward FYI data dump for you. So thanks everyone, and look forward to seeing you next month.
All right. Thank you.
Oh, hang on, everybody. We do see a lot of questions.
My apologies.
So we do have questions for those of you who are still hanging on. So let's start out.
I'll ask the questions here.
Okay.
Let's start with Joe. Non-traffic engineer, data scientist working on local community board, trying to gain some understanding of this realm to better understand all the new development going on in the community, and they appreciate the resources.
Cool.
What different video cameras are taken for different for data collection?
Okay, we've used count cams through all of it, but any camera that'll last days on end, you can use, but that is a
it's really, you're just pointing it at the drive-through from the
and if you
from
can
the
get
order window and trying to make sure you can see everything back.
And if you have a question on that, you guys can email me directly on that. I'd be happy to talk to you about the differences between what ours offer and the ones that are out there. What time period showed the max queue?
So the time periods were varied based on the land use, but what we did is we gathered days worth of data at different sites, and we were able to review the whole day. And so we were really looking for the whole day, what was the maximum queue for the day. And then we had multiple days that we added into it, and those were the maximums we used. So
it's all in the report.
Yeah, so it wasn't, we weren't looking at a specific hour we looked at an entire day to try to figure out what the max was over that whole day.
Have you noticed longer queues during the mid-afternoon period?
Again, go back to the data report. That depends on the land use and
Yeah,
the order board versus the order window. It would be the order board, or if they don't have an order board, the order window.
And
yes.
and you guys explained the 85th percentile. Good job.
Yep.
And
We tried.
now,
There was a second part to that as I'm looking at it, though.
Yep.
They asked if the 85th percentile is 12 vehicles and they have more than one drive-through lane, could they then design for 6 in each lane? And yes, absolutely. So
You might want to design for 7 or 8,
yeah, and that's where we
recognizing the
talk.
imbalance.
Yes, that's where we talked a little bit about the imbalance. There's also some efficiencies gained. If you have 2 windows, there's 2 people taking orders, handing out food, or 2 tellers. So multiple things that can happen. So you're gaining a little, you're losing a little with imbalance, but you're going to be pretty close if you divide it by the number of lanes.
in the drive-through bank analysis, is the queue for just 1 lane or was it all 3 lanes together? What would be the peak time occur?
Okay. We'd have to go back to the
So
report.
yeah, the peak time, again, we'd have to see when that peak occurred. Might have been different depending on the site too. And we looked at all the lanes. What's the number of vehicles in all the lanes?
Was your coffee shop queue data in any way relevant to the size of the shop? And was that relevant in the data?
We didn't go into it that much, and we're dealing with small samples, so it wasn't relevant at this point. Most of the coffee shops were pretty similar in size from what I remember.
Yeah, but intuitively to me, they should not be dependent because there's the demand for the drive-through, the demand for the seating area. There are some coffee shops that have no interior seating. Yet they have very busy drive-throughs.
Mm-hmm.
So I don't think that would be predictive.
Someone brought up a point of the drive-through queues can be getting longer because you can now order 240 types of food or coffee, not just burger and fries as it used to be.
Yep.
Did you find any difference in queue times by the day of the week for fast food?
We don't have enough again, this is like we're talking about with the size of the building, with adjacent street traffic, stuff like that. We don't have a robust enough data set to start splicing it out that way.
Yeah. What we're really doing is looking at the maximum, so then we could design it for that maximum. So there isn't much point in knowing that Wednesday is 80% of Thursday when we're designing for the maximum.
Now here's something interesting, you guys. They typically use 95th percentile in California as the design queue for storage lanes and drive-through queuing. What is the change in your results basing on the 95th rather than your 85th percent?
Well, I think my math skills are good, but I don't know that I can quickly do that adjustment in a few minutes.
But our 85th in most cases are actually really close to the maximum.
Yeah.
So
maximum of the range we saw. So I don't know that it's going to change.
I don't think it would change. You could jump straight to the maximum in most cases, I think, but you can refine the statistics based on what we have in our report.
Here's something about a possible future research study. Do you have any studies on daycare centers such as drop-off or pickup lane queuings for daycares?
We do not.
No, we do not. I haven't worked on too many daycares. But that would be interesting.
Yeah. Mm-hmm. And if anybody's in Vegas, we could use some wedding chapel drive-throughs too. So that'd be fun.
That would be interesting to see.
Are the queues based on the maximum regardless of the drive-through lanes?
Yes.
Okay. It's the maximum number of vehicles.
And have you differentiated drive-through queues between burger-type restaurants and fast casual?
They were all fast food per the ITE definition, so we did not look at fast casual, and I believe part of the definition for fast casual is it doesn't have a drive-through lane.
Yeah, they can have the pickup somebody can park and they can bring food out to fast casual, like at a Chili's or Applebee's, but I don't think
it's a full drive-through.
Do you guys have any information on discharge and arrival rates to simulate queues when scaling development sizes?
No.
No.
I mean,
That's
one
like
could
it's-
certainly get that out of the videos and crunch the data in that way. But I don't know if you make a coffee shop twice as big that you induce twice as much demand for a drive-through lane.
No, but I mean, part of it is based on how they operate the drive-through,
Yeah.
which is why a bigger sample size should get us there. But
Yeah, and clearly the dissipation rate through a Starbucks is a whole lot faster than through Goodwill, at least based on my experience. The
Right.
service rates.
Right.
So just to confirm, the length that of drive-through lanes for coffee shops and fast food restaurants are from the order board, correct?
Correct.
Correct.
Yeah, we thought that made the most sense for what we were looking at.
Any comment on banks and coffee shops having an 85th percentile Q value that's greater than the average maximum value?
Well, they were all greater. So we looked at the maximum value for the sites, and from that we compiled the average, and from that we also compiled the 85th. So they're both based on the same data set. So the 85th percentile is always going to be greater than the average.
Yeah, because by definition,
Yeah.
average is.
Average is 50
50.
percentile.
Yeah.
And many ITE define fast casual restaurants like Panera Bread and Chick-fil-a, which now have drive-through lanes. Do you have any plans to study those?
Right. Again, I'll have to go back and read the ITE definition because I didn't think fast casual had a drive-through.
Yeah,
So-
but if you have that data, I honestly don't know of any Paneras or Chipotles in our region that have a drive-through window. I have not seen that. So,
I think there's one in Mankato.
There is
Okay.
one.
okay,
Yeah.
so if this is a new trend coming, we obviously should be studying that. And if you have data, please share it.
Yeah, Chipotle though, I don't know that they have. I don't know that
I-
I've seen a
I-
drive-through for them either. Anyway, I would have to go back. I'd want to reread the ITE definition. I'm just going off the top of my head, but I thought one of their criteria was that it did not have a drive-through.
Yeah, so would that mean then that if Panera puts in a window, it converts from fast casual to fast food?
Per the
Mm,
ITE
the definition.
definition. Yeah. This would also be a case that if we were looking at something like that, I would probably want to go get local data.
Go study 3 Paneras
Yeah,
that have the
whatever ones
drive-through
I
window.
could find.
Yeah, especially new cutting edge.
Mm-hmm.
And that'd be the questions, gentlemen.
Thank you, everyone.
All right.
Thanks for hanging with us.
Thank you.
Yeah, thank you.
All right. Have a good one.